I'm Mr. Kangas, and this is Chapter 3, Section 1, Distributive Property. So, in the order of operations, parentheses come first. That means you have to get rid of the parentheses before you can move on and do any other math in the problem. Now, sometimes a situation comes up and it looks like this. There's a number right next to the parentheses, and there's no sign between the number and the parentheses. That means multiply. So, this is telling you that you need to multiply this 4 by what's inside the parentheses. So there are two ways to solve this. One of them is with distributive property, but first I'm going to show you the way most of us probably look at this and solve it. When we were taught, you do what's inside the parentheses first. So 3 plus 7. You get 10. Now, because there's no symbol between the parentheses and the 4, when I get the 10, I need to keep the parentheses there, just so that I know I'm multiplying 4 by the number inside them. At this point, there's no more math left in the parentheses, so I've completed my objective up here. Your objective up here with that P is to make sure all the math inside those parentheses is gone, or making sure that the parentheses go away. So at this point, you can do 4 times 10 and get 40. Now the cool thing about multiplication is if I'm doing 4 times 10, okay, I can split one of these two numbers up into pieces. I can split one of these numbers up into pieces. So for example, I can do 4 times 5 and 4 times 5. So I split my 10 into two 5s. It equals 20 and 20. And so I still get a combined answer of 40, as I would have if I did 4 times 10. Most people who do mental math do it in pieces like this. People who can multiply big numbers in their head do it like this. And what I just showed you is actually distributive property. It just isn't in the right format. It doesn't look like it's supposed to. But it is a version or form of distributive property. But we'll get more into that in a minute. Now, what distributive property is telling us is that we can take the 4 on the outside, and since it's being multiplied by the parentheses, we can multiply the 4 by both numbers inside. So I can do 4 times 3 and 4 times 7. And I can keep the sign between them. So it's telling me I can do 4 times 3 plus 4 times 7. 4 times 3 is 12. 4 times 7 is 28. And 12 plus 28 is 40. Just like it was over here. So the key to understanding why distributive property works is understanding what multiplication is. Multiplication is repeated addition. So, for example, over here we added 3 plus 7 first, got our 10, and then we did 4 times 10. So we had 4 times 10. What that's telling us as far as repeated addition goes, because multiplication is repeated addition, that's telling us I am adding 4 10 times. So 4 times 10 is the same thing as doing 4 plus 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 4. Okay, a lot of 4s. I probably should have chosen a smaller example to start. We'll get into one after. So I'm adding 10 4s here. So if I add 4 10 times, I get to 40. Distributive property is telling me that I can, instead of adding 3 plus 7 first, I can take the 4 times 3 and add it to whatever the answer to 4 times 7 is. So let's take a look at what that shows us. So it's telling me I can take the 4 times 3 and add it to the 4 times 7. 4 times 3 is telling me to add 4 3 times. So there's my 4 times 3. 4 times 7, or then I'm going to keep the sign between them, which is plus. And 4 times 7 is telling me to add 4 7 times. So you can see here is 4 times 3 and here's 4 times 7. And if you take it all and put it together, I have 10 4s being added together. Just like I do over here. Same exact thing is going on. So, distributive property in the traditional method work exactly the same way. They just have two different ways of going about getting it. In the end, no matter which method you use, you're still adding 4 10 times. It's just how do you get to that point. Now, at this time, many of us are probably sitting there saying, well, why would you use distributive property when this way is obviously shorter and easier for a lot of people? There are two reasons why I would use distributive property, or 2 places where I would use distributive property, and I'm about to explain them now. Distributive property comes in big time handy when variables are involved. So, for example, if I had something that looked like this. Now, traditional method says you need to do x plus 3 first, then multiply by 4. The problem is you cannot add x and 3. We don't know what x is, so you can't add them. And as you'll learn in future sections, I believe chapter 3 section 2 will talk about like terms. Like terms are terms that can be added together. They are terms that end in the same variable. This term ends in x, this term has no variable, so they are unlike terms and cannot be added. I have no idea what x is equal to. I know 3 has a value of 3, so they can't be added until I figure out what x is. However, distributive property lets me work around that. By taking the 4 on the outside and multiplying it by both numbers inside, I can get rid of those parentheses. So, now I can do 4 times 3, which is 12, plus 4 times x, which is 4x. And at this point I am done. This is as far as I can go. But what I've done is I've simplified my problem. And we'll talk more about the purpose of simplifying an equation in future sections. But just so you know, I said you couldn't add x to 3 because we didn't know what the value of x was. A lot of you are probably sitting there and saying, well, if you can't add x to 3, how can you multiply it by 4? And the truth is I actually didn't multiply 4 times x, because when you see 4 next to x like this, it means 4 times x. So all I did was I wrote down what it is I know I have to do, but at this point in time can't do. So just as a precursor to the next lesson on chapter 3 section 2, I can't add 4x and 12 because they're unlike terms. 4x means I'm adding x 4 times, or I'm adding 4x times. I can't do that. I don't know what x is. Okay? And that has to be done first. I have to multiply 4 times x first before I can add 12 to it. Because the order of operations tells me that multiplication comes before any addition. All the multiplication has to be gone before any addition can happen. Multiplication is here, and I can't solve it, so this is as far as I can go. But again, simplifying these expressions will come into play more in future sections. And you'll see why it is it's so important to be able to simplify them. So, just real quick before we end the lesson, I'm going to do a couple examples just as a reminder. Okay. Really important you remember with distributive property, that you bring the sign down. Sign stays the same. 4 times 3 minus 4 times 2. 5 times x plus 5 times 4. 4 times 3 is 12, minus 4 times 2 is 8. The answer is 4. 5 times x is just 5x, plus 5 times 4, which is 20. So, earlier I said that there are 2 places where distributive property comes in handy, and I pointed out the variable situation where we need to use distributive property to get rid of those parentheses. The other place where distributive property comes in handy is when you're doing mental math, big numbers in your head. So if you're doing, for example, 13 times, let's say, 54. Okay? In my head, when I do that, I break down there are 2 things you can do. You have to choose one of the numbers to break down. You're going to use distributive property here. So for example, I could say 54 times 10 plus 3. So I broke down my 13 into 10 plus 3 in my head, into a 10 and a 3. So I'm going to do 54 times 10 in my head. Multiplying by 10 is pretty easy. You just add a 0 on the end. Then I'm going to do, my bad, just add a 0 at the end of the number. And you do 54 times 3. Gets you 162. Add them together. And even with addition, you can break it down. You add 100 to the 540, and you're at 640. Add 60, and we're up to 700. Add 2, and you're at 702. So, just thought I would briefly go over how to do distributive property in your head when doing mental math.